So we'll have a good look at the first two major assignments, and then the large research assignment that will come out when the first assignment is handed up. And then beyond that, we'll finish where we left off with consultants and authorities as well, and that will put us at a, I guess, and we'll stop it at that, because that will put us at the same sort of spot as the Monday's class, who obviously this coming Monday have a public holiday. So next week we'll all be matched up with them at the same time. So it'll make today's class a bit shorter. You guys, is that okay? Everyone's fine with that? And excuse me, I'll grab your name, Charlie. Yeah. Right. Thank you. So the assessments that we have in this subject. So they're the Moodle quiz. And has anybody had a look at the Moodle quiz yet? I haven't gone on to go checking people. Yeah. Cool. Yeah. This first one was very simple from recollection. Yeah. Very simple. So yeah, it's a weekly thing. I suggest do make it a weekly thing and go on there weekly, rather than toward the end of the semester I'll have to chase you and go, oh look, you've got a dozen Moodle quizzes to get to fit in at some point in time, and you'll be going, oh, I've got everything due at the moment, not the greatest time. So have a crack at that, and I suggest doing it weekly. Part B is visit a residential construction site and report on one of the given topics of your choice. So with this one, you get to choose whichever one you want to report on. I'll bring that up right now. So assignment 3, part B. And just to reiterate, so you're required to complete a report on your observations of at least one residential construction site. The report should include details of the type of construction and the suitability of materials and methods that are being used. The report is to be of at least 600 words, your own words, and is to include pictures and sketches taken by you of the site. So at least 600 words, but I think an important thing to note is a report is about being succinct and about conveying the information clearly and accurately, and not including information which is irrelevant, or essentially text which is, for want of a better term, flowery or overly descriptive or emotive. We're talking about the conveying of information, the recording of information, and the deciding of what information is most important to the client, or myself, the reader. So I say take consideration of the word count. So that's a fairly good guide as to what you should have in there. But by no means should you be padding out a report with superfluous information to reach that 600 words. If you find yourself doing that, then there's probably an issue there in what you still need to research. So you can choose which report to do, depending on what may be available for you to find. You must complete at least one of the following 7 reports. And I'll just quickly go through. I'll read this bit out first. So when visiting sites, you must have permission from the builder or site supervisor. You must have a current white card and wear the appropriate personal protective equipment. Does everybody here have their white card? No? So there's some people without a white card. Actually, hands up if you don't have the white card. 1, 2, 3, 4, 5, 6, 7. Okay, yeah. So quite a percentage of you. You guys booked in to do the white card at some point in time? Yeah. So yes. All. And there's somebody who doesn't have their white card who's not booked in. Right. Okay. Yeah. Okay. But so everybody's in the process. That's great. Yeah. Because it's something that you will need. not only for studying here at TAFE, but for working professionally in so many senses. So and the new white card is fantastic. It's not like the green card. When I first got that, it would expire every year. The white card, once you got it, and it's yours for life. So get that. Also, steel cap boots. You want to have or have access to steel cap boots. Everybody's got access to some steel cap boots. So that's something you'll need to sort out. Those two things are the basics of what you'll need to gain access to a construction site. Some other PPE you may need to have is high-vis, so high-vis vest or top. You may need to wear a hard hat. You may also need to have sun protection on some sites and hearing protection on some sites as well. So observe. Typically, a lot of building sites now with the site fencing around the outside have information on there about what the PPE is you need to enter the site. But that information should also be available from the site supervisor or builder when you have a chat with them to ask if you can gain access. In many instances, if you're dressed appropriately, you're able to arrive at site and there will be somebody there who has the responsibility to allow you onto that site. If that's the scenario, that's fantastic. That's the quickest and the easiest. If you have to go through phoning up a builder, I've found quite often speaking to the builders or site supervisors, they've been very good in letting people on site, particularly when you explain that you are a building design or construction student and you're doing this for TAFE. But from time to time they will say, no, we can't let you on site because you're not covered by insurance, and I think at times that's also used as an excuse because they just don't want the hassle. But if that is the case, on Moodle here there is a site insurance letter to show the builder to say that you are covered by insurance for TAFE. So if you have that said to you by a builder or site supervisor, you can first up say, yes, I am covered by insurance for TAFE, and that shouldn't be issued. If you want to see the letter, we can get that for you. So there are your options. Because there are at times issues for getting onto sites, I think this one is a really good one to get going or sink your teeth into straight away. Many of the report options we won't be covering until later, but it also gives. But if you get onto this quite soon, it gives you the opportunity of researching that report option, having a look at what you do know, what you can find out yourself before we actually cover it as a topic. You can still go onto site, but when you're on site, take a lot of photographs. So if you're chosen report option, if you haven't covered that yet, just go taking lots of photographs, close-ups and further out, so that when you go to do your report and you are lacking some information, you can go back into those photographs and find out that information that you need. As I said with the photographs, take photographs that are nice and close, and then take photographs further out as well. What I find quite a lot of people do on site when they're taking photographs of details, they'll just take a photograph of the detail and then not show that in context. And when you typically with timber framing, things like this, it can be hard to identify exactly where that was and what the situation was and what the context was. This is quite often important. If you are unable to find suitable sites to complete your report, you may use the internet to complete or add, providing it is from Australian sources and South Australian construction methods and techniques. That's the least preferred option, but it's still possible. Some students are unable to get onto sites, and so that's an issue. But if you are having difficulty accessing sites, just let me know first. I might be able to get you onto one. And there's still plenty of building work which is happening just in around this area. A lot of urban infill in this section here, so you should be able to find a site close by. So the report section is listed below on individual pages. So our first report option is you can do a report on footings. So the following points relate to a raft, stable, domestic building and should be covered in your report. So it's asking for compacted fill, type of compacted fill, thickness and compaction method. And we'll know a little bit more about that after next week's lecture, as we'll be covering all of these things. Footing trenches, how the trenches were set out. Is it possible to see whether they used timber hurdles for setting out string lines or steel pins? The method used to dig the trenches, so excavated backhoe trencher. Are the trenches well shaped? If not, why not? And what type of termite barrier was used? Actually, I think it may be fairly tedious if we were to pour through all of these individually, and they will make more sense as we cover them in the topics. But the main point I wish to make from here is that once you identify a site, I think the best course of action is identify a site and go, okay, they're just doing the site works now. Let's say for footings, they're doing the site works now, they're scraping away the top of the soil, they'll be doing excavation fairly soon. Speak to the builder if you can gain access to that site for when they're doing work, or if you can take suitable photographs from on the edge of the site. With footings, typically you can. Decide that, and then go and then produce a skeleton for your report. Now, a really good way of producing a layout or skeleton for your report is to grab all of this information in the assignment literature and get that into a report. So you've got your heading and your subheadings. So we go, you produce an introduction to explain what your report is about, but then beyond that, you can say, we are covering compacted fill. You can use that as a heading, and then you can use type of compacted fill as a subheading and talk about the type of compacted fill they use, whether that was quarry rubble, whether it was site soil, whether it was clean fill from another site, whether it was dolomite, whatever. Speak about that. And then use thickness as another subheading and talk about the thickness. And when and for example, if you start getting fill that's thicker than 150 millimeters, it'll need several layers of compaction. We'll go through that next week. So with your report, get your structure happening, and when you get your structure onto a report before you head out to site, that will tell you some of the things you can already answer about that, some of the things you already know, and then some of the things you're going to have to find out and research. And so that's a really good guide as to what to think about when you get on site. So if you've already got that report structure happening there, and then it's going to be much quicker and easier on site. Of course, take this report or this assignment with you to site as a checklist. So have a good checklist on site. Take plenty of photographs, make plenty of notes, and then the actual filling out of the report should be relatively straightforward and simple with a bit of research. Yes. Oh, sorry, I thought you had your hand up.
I'm unable to reach this. Where is that?
Oh, right. So that's in assignments. So just scroll down the page a little bit, or assessments, sorry, and then assessments. Assignment 3 Part B is what we're looking at. Right now. So, of things we've got to choose from, we've got to choose from footings. We've got to choose, or we can choose timber wall framing. And in brackets there, that's masonry veneer construction. And the reason it says masonry veneer construction is because there are some aspects specific to masonry in here, masonry veneer. So that's basically brick veneer or it could be Hebel veneer, but that's where we have timber stud framing and an external masonry veneer on the outside. We have steel framing as an option. So in residential, that's typically going to be cold rolled steel framing. We have suspended upper floors. That one's a little bit trickier typically to get onto site when they've got suspended upper floors. So obviously you're going to need to have a 2-story building to do that. So it limits the sites. And then also at that point in time, you might have tilers on site, putting tiles on and chucking down the rest and whatever. Builders don't really want students on site. That is happening. But we get a couple of those. Trussed roof. If one really good thing, if you have chosen to do the trussed roof report, a great thing to get, either a copy of or even a picture of, is the truss layout diagram for the building, if you're there. So if you see the builder on site, or if anybody on site has the timber framing information and the truss layout diagram, grab a photo of that and get that into your report as well. And that also helps you answer a lot of these questions as well. We have the option of doing brickwork. And finally, linings and second fixing. It can also be a little difficult to get onto a site where they're doing linings and second fixing, because this is typically done once the building isn't locked up. So once it's weatherproof, all the doors and windows are in place, it's when they get the linings and second fixing happening. And this last one, that's fairly details heavy as well. So if you enjoy drawing construction details, then this one's a good one for you if you get onto site. Close that down. What I do have are a few report examples from previous semesters for this assignment that we can have a quick look at. So with this report, they've gone through and they've taken note of the information that is required, added photographs and some fantastic photographs, so got good clear photographs that are easy to see and details of reasonable quality. With any of your drawn details, you can do that in a CAD program if you wish, or you can do it by hand if you wish, whichever you prefer. Obviously, CAD tends to be a bit clearer and can be.
Where is that one located?
What's that?
Where is under which title this?
Oh, these are ones you will not have access to. So these are assignments done by other students, and so I'll show them to you in class here, but I will certainly not give them or make them available to you because it opens up temptation a little bit of plagiarism. So this is just, for example, in the class and on the video for external classes. So made notes about, so common stuff was 90mm by 35, that was spaced at 600mm centre, had a stand 565, so a bit of an issue with that. You talk about studs, we've got spacing, we don't have stands for studs. Made notes about all the timber. Primarily what's good about this report are the details and the photographs. So good details and photographs. Things I would add to this report are headings and subheadings, because typically with report structure we have headings and subheadings, so it's easy for the reader to flick through and look for the various bits of information they need or want in that report, and it helps with the layout, and it also provides you with a checklist of the information provided for your report. So that's something I would improve on this report. Also, having information about the photograph and what is shown in the photograph. So
Because this is all. Last night I was studying the assignment one. That is, we have to submit by 13th of April.
Yes. Yeah.
There I saw it is from the start, but these buildings are under construction. Like they are at the later stage. So from where, which part we have to use? Either we have to start from footing, or we have to do once they are raised and the timber framing has been done. Which part we have to?
Yeah. You can choose. So yeah, because you came in just a little bit late, you sort of missed the context of the discussion there. I'm sorry I didn't bring you up to speed at that point. But there are several assignments we have to do for this subject. So the one you were researching last night, I'll go through that next. So that's the first one you should get stuck into. But I'm introducing this one today as well because really we need to get started on both of those to begin with. So with this Part B report.
It's Part B. Okay.
Yeah, so this is Part B, so it's assignment 3 Part B. You have the choice of various different reports you can do. So you have 7 topics to choose from, and that can be about footings, it can be about framing, it can be about masonry, it can be about internal linings, it can be about trussed roofs, etc. So all of those options are there. Choose one of them, whichever one suits you or suits your site. So I would, so improvements to this, headings, subheadings, and information about photographs. Also, some students who've got the programs on your computer for annotating photographs, that can be really handy as well. So for drawing in, okay, this is let's call it a sail over truss, or we can I don't know what. Let's pull out this lintel here. So we circle that and go. This is an LVL lintel. It was 300 by 63. A very large lintel required to span this distance of what looks to be like maybe 3,200, like 3.2 metres or so. So annotate your photographs as well if you have that capacity. This next assignment, fantastic in terms of adopting that process of headings and subheadings, but that's about as far as I would go for praise on this assignment. Very lacking in information, lacking in photographs and details, not at all annotated or particularly clear to the reader. So they've done that. This is basically what I would have as my skeleton of the report initially, and then I would add a lot to this. And then finally, a fairly good mix of both. So we've got yes, they could bolden up their headings and subheadings a little, but they have broken it down into providing a background of what it is we're looking at and what the subject property is, given us a subheading about wall frame timber species, provided a hyperlink. I haven't opened that. This is not one of my students. So the wall frame is made from machine graded pine, produced by AKD, which sources timber from estate growing trees. It's applied to, so they put in the relevant Australian standard for assessing and producing timber, and they've grabbed a photograph of that and then provided a link to the manufacturer's website, etc., etc. So gone through headings, subheadings, relevant information, and relatively clear annotated details.
Currently, how many assignments, like today we are discussing?
We're discussing 2.
2?
Yeah.
One, that is Part B, assignment 3?
Yes.
And what is that one? Is that the same?
This is the same. So this is, so there are, So there are the 7 different options you can choose from for that assignment. This student has chosen the timber framing option.
Like we have to work it on one option, or we have to select 7 options?
We have to select one option from those 7.
7.
So you're given
Are
7
they
options.
located here in assignment 3?
Yes. Yep. So if you get onto that and you scroll down, so that talks about what's required in the report, and then you've given option 1, and keep scrolling down. Option 2, option 3, option 4, etc. And you have to choose one of those.
One of, and we have to work according. We have to make a report out of 1 out of 7.
Yes. Yep. So make a report. So you choose truss roof. All you need to do is to do the report on the truss roof, and this is your guide as to the information, or the minimum information which is required. You may find other information that is relevant on site and interesting. Get it in there by all means. That's your minimum requirements set out there. So that's some examples. And so this final one, this is more toward what I hope you would produce. So something good mix of details and drawings using headings and mention of Australian standards and the introduction of some hyperlinks. That one as well. Don't need that one anymore. So that's our assignment part B. You'll notice, so on my screen you can see that research assignment 2 part D is greyed out. So I can still see it on my screen. I don't think you guys can see it on your screen at all, can you? Yeah. So I haven't. So that's it's sitting there, but you can't reach it. Leave that one alone for now. But the one that you will have to get cracking on primarily is this one, the part research assignment part C, and this is based on information that we covered in the lecture last week, and a little bit today. So we'll touch on some of this today as well. Although some of it will have to come from your own research. It's not. So the actual, how do I say it? The actual contact with the council and the interaction with their websites is something that you have to do and learn yourself. So it says, imagine you are a building designer intending to build a single-storey brick veneer dwelling at your current residential address. So single-storey brick veneer dwelling, very simple house like what is built in most, large-scale residential developments today. So it's a very, very normal house. And assume it is currently a vacant block of land. So many of you will live in older areas that have had houses on them for 40, 50, 60, maybe 100 years. Assume that the house you're living in is no longer there, and it's a blank slate. If you happen to live in an apartment, just assume that it is a vacant site, and you are building a single-storey detached dwelling on that. So first up, research what brick veneer is and briefly describe the construction of such a dwelling. List your ideas of the pros and cons of building with brick veneer. So that should be fairly fairly straightforward. So what is good about brick veneer? Why are so many houses built from brick veneer? There obviously must be some good aspects to it. Comprises the majority of dwellings. But what is also bad about brick veneer? Why is it not good? Can it be improved? Are there better methods? Collect appropriate documentation outlining the process by which you will need to apply for development approval from your local council, as well as the following new service connections.
Michael, I'm
Yes.
sorry to
Yep.
What do you mean
Yes,
by
okay.
the pros and cons of building? What does this mean?
So pros are the good things. So that's all the things in favour of building with brick veneer.
Okay.
Yeah, and cons are all the bad things, all the things that count against building with brick veneer. So collect appropriate documentation outlining the process by which you will need to apply for development approval. So that information, typically on council websites now, is very clearly explained on the websites. And what happens now is predominantly to complete this portion of this assignment, and certainly the council aspects, that information is contained online, and you probably will not need to speak to anybody within the council. So pour through their websites. Some councils haven't, really got up to speed with getting all that information on there, but they're predominantly outer metropolitan areas. So if you live in a metropolitan area, it's quite good, or even the hills and Alexandria, etc. They're quite good as well. So go onto the websites, and they should clearly define what you need to do for development improvement. But we've also covered this in the lecture as well. So discussed the gaining of planning consent initially, and then the building rules of consent. So it's about what you need to do to apply for both of those. And as well as the following new service connections. Water, we need to work out, so we've got water, sewage, gas, electricity, and telephone. Telephone's not such a major one these days, as many people aren't going with landlines. So if you wish, supplement that with NBN. Okay. Gain information about what you need to do to hook up to the NBN, if you wish. So clearly identify the name of the authority for the service it provides, and include completed application forms where appropriate. So from their websites, you should be able to get the application forms for that. If no application forms are available, outline in your own words the process involved in having these services connected, and specifically what information you need to provide in terms of the building design. Also, ascertain from the supplier who is responsible for such things as trenching, cable laying, wiring, pipe laying, or any other tasks that may need to be organised by you as the building designer or the owner you are acting on behalf of, and when these tasks need to be undertaken. That is actually the tricky bit of the assignment. Some of the service providers are not, or they're not really forthcoming with that information. You have to dig around a little bit to find out who is actually responsible for the trenching and pipe laying. Is it, right? So let's say I'm getting electricity. Now and I'll talk about electricity, but for the others, you guys do your own research in finding out who you need to speak to. But for electricity, it's going to, for residential work, it's going to be SA Power Networks. So the structure of our power supply here in South Australia is that we have two owners of the infrastructure. For all your residential 415 volt and lower, it's SA Power Networks for all your residential supply. For all of your major infrastructure, all the high tension power lines, all the large power distribution networks, that's owned by Electronet. So we've got two different owners of the infrastructure within South Australia. So SA Power Networks are the ones that you're going to be dealing with. Now, to get anything done through SA Power Networks, or any connection done, you're going to have to do it in accordance to what they stipulate, and they have very different stipulations for various different areas. One interesting one for rural connections is that you now need to have a meter box within 10 metres of the front of the property. So if you're building a house 50 metres back into a block, you actually have to have an outdoor meter box located near the property boundary, and they're fairly uncompromising on that feature now. So there are but I'm saying that because there are various different aspects when dealing with SA Power Networks about the type of thing you're going to have to do with SA Power Networks. But given that scenario, so I've got my meter box 10 metres in from my boundary on a rural allotment. I need to employ an electrician who is certified to work for SA Power Networks. So an electrician who's associated and has the approval of SA Power Networks to work for them and to modify any of their infrastructure or join up to any of their infrastructure. So I can't just get my mate who's an electrician to do that work. It has to be somebody who has that association with SA Power Networks to begin with. Then either I do the trenching or the electrician that I employ does the trenching. And then I pay for that. And then they supply, well, obviously the electrician supplies the conduit and the cabling, etc., and does the work at my expense. But the quirk of it is that SA Power Networks still own that infrastructure. That infrastructure that I've paid for and had to install up to that meter box, that's still owned by them. So I have to pay for that supply. But then from there on, I can use whatever electrician I want, and I can have, I can do the trenching myself, or they can do the trenching, etc. So I'm not restricted. Once we're past the service fuse located in the meter box, then it's all up to me and what I want to do. That's that scenario. Typically, with a residential building in an urban setting, we're going to have the meter box located on the house. SA Power Networks or their contractor is going to be involved in the process of getting the power all the way to the house, and then we can use whatever electrician we want to internally. Yeah. So that's just for electricity. So we've got that supply, and we have to create that distinction between retailers of electricity. So we've got all our retailers of electricity, be that AGL or Energy Australia or whatever. So there's all these different retailers, but they are not the people we go through for provision of the service. And you will find that with water and gas as well, or water, gas and sewage. Not that we have retailers for sewage, but be aware that yes, you might be able to get this information if you go via the retailers, but it's better to find out who are the owners of the infrastructure and who we actually have to be working with, apart from the retailers, to get a connection. So that's just a tip for that, and dig around and find out.
Like my experience with dealing, I have seen with every house there is a sewerage line connected with the footpath, and then plumbers have to work it out and connect all the lines with that.
Yes, yeah. So yeah, but what you will need to do is go on. So for sewage, I'm not going to tell you who you have to speak to for sewage. You guys have to work that out yourself. Find out the information that they have online, or possibly even speak to somebody about who is responsible for laying that pipe work and doing the trenching, and who owns that infrastructure afterwards, and from what point. Does responsibility terminate at the boundary, or responsibility for works terminate at the boundary? Does it extend to the house? Does it terminate at the junction with the main sewer line? So you need to determine those things yourself and work out that, and whether it's you can just get any old plumber to do that, or whether it has to be a plumber with an association with the supplier. So that is the first one that is due, and that is due on the 13th of April. So got about a month. Yeah.
What if you place it as self-sustainable?
Well, that's going to be interesting. By all means, answer that. Actually,
I suppose you just.
although yes, I'm very interested in that, and I like that approach, and for someone to say, well, look, I don't have to rely on anybody for supply these services. I think for the intents of this assignment, well, what you can say is, look, my house is actually autonomous. It doesn't need reticulated water. It doesn't need electricity, etc. But say if I were to join the main system, this is what I would have to do. I assume that your place, Bugle Rangers, is not going to have main sewer there. Well, no, that's a very safe one. It's not going to have main sewer, right? You're going to have to sort out on-site wastewater. Unfortunately for you, that's a whole can of worms, but it's going to be a great exercise for you to go through, and possibly something you can present to the class as well from your findings about the regulations surrounding on-site wastewater and the minister's specifications for that. If you need any help with that, I can furnish you with the information for that, but I think it's best if you dig around and work out what on-site wastewater options there are. And then once that's done, I think we'll have a bit of a discussion in the class about on-site wastewater as well.
Michael, one thing that will worry, like, to complete the assignment,
Mm-hmm.
if we approach to any builder, like the companies who are in this field, will they allow us to work with them, or no? Most likely they will not allow. Like, to work it out, this proposal, if we work with some construction with the builder who is already in this process, are we able to approach them? Will they accept us easily? That
I think this is the approach to this assignment is far better if you do the research yourself and take yourself through all of this.
okay,
Because there is so much, there's all this publicly available information there. So all the information you'll need for this is from your local council and from the various different infrastructure owners and their websites, and possibly phoning them up, but it should all be on their websites there, because it's all publicly available information. I think it's best that you do the research yourself rather than try to get a builder to explain all of those things to you, because it is a lot. It's a lot of information, but it's also freely available to everybody. So yeah, so that would be the best approach. Talk to some builders if you wish, or you have contact with builders. By all means, talk to them about these various different things. They might be able to point you in the right direction. But you're going to have to download application forms so for the council and for the various different services. So you're going to have to go onto the websites anyhow and do all that work. So yeah, I think independently this one is better. So that's the first two assignments to sink your teeth into. So beware that first one, that's due in a little over a month's time. The second one's not due until the end, but it's good to get started on that one early. So, as I said before, we'll just go through the tail end of consultants and authorities, and then after this week and the public holiday, that will put us in at the same position as the other class. So we're up to documentation. I may have a set of plans. I actually know the plans I have aren't fantastic. I won't pass them out. But is everybody here familiar with a full set of building plans? Have people seen building plans, or some people that haven't seen a full set of building plans? Anyone? You haven't seen a full set of building plans? Or you have?
yeah,
You have, yeah. I thought, because you work for Geno's, don't you? Like,
Yeah.
there you go. So it sounds like most of us have some idea of plans. Plans, well, when we're determining how a building should, or describing how a building should be built, so we have to provide that description to the council and provide that description to the builder. Plans should be read in conjunction with specifications. The reason we have both plans and specifications is that specifications handle all the wordy components, all of the little bits and pieces that we would not want to put on our plans, because it ends up making our plans really busy and really confusing, and it's difficult to contain all that information on. But conversely, we can't just describe how to build a building from a specification. To provide a description of, let's say, provide a description of that column. I guess actually that column we could describe, it's a 450 diameter concrete column with whatever, 18mm bar reinforcing with whatever ligatures, etc., 32 MPa concrete, etc. And then we could say that those columns are spaced evenly at a 6 metre grid. But what we cannot easily convey is where that grid starts, what position on the ground that grid starts, and then how far that is from another certain feature or so. So there's a great deal of information about building which is much easier to convey on plans than it is in a written sense, so in the specifications. But they should always be read together. A legal quirk of this, well, what is really good practice as drafters is to ensure that you're not doubling up information between the plans and the specifications. You either choose to cover something in a specification or you choose to cover something in a plan. The main reason for that is it makes it so much easier to manage later on if you're making any amendments. So if you're called on to make an amendment and you've specified carpet in your plans and you've also specified it in your specification, you run the risk of the client changing their mind, saying, oh no, I'm going to have woolen carpet, and you change that within the specification, but you may forget to change that on the plan. Or you may have included that information on several plans, you change it on one plan. It gets very confusing, and in that scenario, you then get a builder who's looking at it going, oh, I've got this information on the plans, this information on the specifications. Worst case scenario is they go, oh, I'm just going to decide which one I want to do and do it because it's on both. I don't know what to do. I'll just choose one option and they do it, and then that's the wrong option for the client. So, and then people get angry, at the end of the day. So we don't want to do that. I guess the better case scenario is that builder then phones up the designer or the drafter and says, look, I've got conflicting information on the plans and specifications. What do you want me to do? What was the final decision on this? A funny legal quirk about that is that specifications take precedence over plans. So if for some reason a designer or drafter has put information on both the plans and the specifications, but those bits of information differ, the specification being a written document has legal precedence over the plans. So what's written in the specification is what has to be relied upon by the builder. But yeah, best practice, differentiate your information between the two, don't double up. And that's also the case for plans as well, if it can be avoided. So try not to double up information on several plans. If you're having to do that, and you do have to do that at some time, in some points in time. A great way to do that is by blocks. So if you're, let's say I've got a floor plan underlay and I want to go moving a wall. If I've produced a block, which is the backdrop to all of my plans, I'm a roof framing plan, surfaces plan, all these sorts of things. If I go moving a wall in a block, and you guys will, I guess, some of you may know what I'm talking about now, some of you may find out about this later. I do it in a block, I change that, and the changes go through all of my plans that I've used that feature in. So So once again, try not to double up things between your plans, but if you do, a great way of doing that is actually via blocks as opposed to individual elements that you have to go through and think about what you need to change on each individual plan. Also, what the council will require are engineers' reports. So we'll have to provide typically an engineer's report on the footings, how the footings are going to be designed. When it comes to footings, you do have to shop around engineers a little bit to see who has the insurance and the certification for producing footings. For Geno's, do footings, that's what you do. But not all structural engineers have the insurance for doing footings. Other things engineers will typically have to do are retaining walls over 1 metre height. So if you're including a retaining wall and it has to be over 1 metre height, then that needs to be engineered. Councils may even want engineering documents for structures far less than that. I've had a scenario where I had to reinstate 1.5 metres long of masonry fencing with that tube steel infill, a very simple structure. The council wanted engineers' calculations and documentation on the footings to reinstate the masonry piers for that. So not in retaining soil. So you'll find that various different councils, will want engineers' calculations and reports on much smaller matters. But certainly for retaining walls over 1 metre height, they will. They will want engineers' calculations for any structural steel or steel framing in general, but typically with a lot of timber framed buildings now, builders are introducing structural steel elements to create large open areas and also to provide bracing. So we can provide bracing in our timber frame by strap and sheet bracing as per the Australian standard timber framing code. But sometimes if we want to build a really long skinny dwelling that has glass all across the front, there's nowhere that we can get some of that strapped bracing in or some of the sheet bracing in to provide us that bracing against the wind. Another way of doing that is with structural steel. So large structural steel portal frames included in there. If we do any features like that, that will have to be engineered. So the engineer will have to provide the calculations to say that structural steel can handle the weight, can handle the spans, and produces the bracing required for that wind loading. On wind loading, it stipulates how to go about calculating that in the timber framing code, and once you've had a bit of experience in that, you can go calculating wind speeds and the kilonewtons of force that they impose onto a building and a building of whatever shape. All that information is in the timber framing code to do. Understand that straight out people would not want to be going through that because there are certain implications for if you get it wrong, etc. But it's all set out in the timber framing code. But if you don't want to be doing that, that's another thing that engineers can be employed to do, calculating the forces on the buildings. So for those the racking forces from wind. You'll also have to have or typically an engineer, or you get a soil sampler out to do soil samples on your block, and you go down to about 4 metres. I think the Australian standard calls for 3.5 metres for all your soil samples, but the firm I used to work for would want samples down to 4 metres. And that's for getting soil samples, for doing the bore logs. And the way the bore logs are done, so it's the soil samples are a large push tube. So typically if it's a site you can get a vehicle onto, you got your soil samples that head around in their Land Cruisers with this push tube set up on the back. And it's a stainless steel tube about this big. And they just push it straight down in the ground, and then join another one, keep pushing it down till they get to about that 4 metres, and then and start ratcheting it up, taking it apart, knocking the soil out, and you get these columns of soil from the top of your soil all the way down to 4 metres, and that shows all the various different horizons of soil. Then the engineer can have a look at that and say, this is the type of soil, this is how reactive it is, and they will attribute what are called Y values to that. So the Y values are how much, on a worst case scenario, we can expect that soil to expand when in the presence of moisture. Can't think of all my categories there and what the Y values are for low reactivity, medium reactivity, high reactivity. Somebody might. Does anybody know that off the top of their head? No. But when you start getting Y values of 100 or more, you're on an extremely reactive site. So you've got to deal with a lot of soil movement when in the presence of moisture. So that's the ones to look for. You're going to have to show that you or your builder has indemnity insurance. So the builder's indemnity insurance. The indemnity insurance covers the client or the person who's receiving the house from any poorly done work or incomplete work. You're going to have to show the council that you've paid the Construction Industry Training Board levy. So that's a levy that's imposed on all new constructions. And that's a 0.25% of construction cost. And you're going to have to fill out the application forms, etc., for both planning and building development, and then pay the council fees for that. Other important documentation for assessment for development application, if we're doing on-site wastewater, is that we're going to have soil samples done for determining whether we need to do soakage, the soakage pit. If we can do soakage, then that's obviously that is the cheaper way to go about it. If the soil has too much clay in it, we don't have the space for doing soakage, then the aerated septic systems that have chlorination and sprinklers above ground, or the dripper systems specified. It is the case now that if you're doing an on-site wastewater, if you don't have mains sewer connection, and you're putting in a septic tank with the associated infrastructure, that system needs to be designed by a wastewater engineer. Now, so when you go for development approval, so not just building rules consent, prior to that you will need to employ a wastewater engineer to design an on-site wastewater system for that house, and then all those details and drawings will have to be included with council when you go for development approval now as well. And that costs around the $1,000 mark or so for getting all that work done. So our typical site plan says site plan here 1:500, showing allotment boundary easements. By and large, the majority of site plans are produced at 1:200 scale. On your council website, they should give you details about the plans that you need to supply for planning consent and building rules consent, and they will stipulate their range of scales. They will say site plan 1:200 or 1:500, floor plans 1:50 or 1:100, etc. So they will stipulate their sizes for that. You'll notice that for building documentation, typically, like some engineering documentation differs from this slightly, but they're the exception to the rule. The rule is, for all the documentation, all the plans that you'll be providing to lay out what we're doing for building, are going to be in scales of, so all your details are going to be 1:5 or 1:10, or some details 1:5, 1:10, 1:20. Your sections are going to be typically 1:50. Your internal elevations, so for kitchen and bathroom layouts, are going to be either 1:20 or 1:50. Your floor plans are going to be almost always 1:100. sometimes with tiny little structures we do them at 1:50. Let's say we're building an external laundry, a detached laundry or something. It's a very small structure. We'll do that as 1:50. But typically your floor plan will fit well on an A3 page at 1:100. Then your site plan is going to be at 1:200. And if you're doing a locality plan, that's going to be at 1:500 or 1:1000 for a broader locality plan. But what we do not what we do not deviate from are those scales. So I'll just quickly jot those up on the board as well. Can anybody think why we would not deviate from those scales? Why we would not produce something at 1:250, for example?
Builder might read it wrong and build the house the wrong size.
Well, that's pretty much it. We might be able to buy an engineering scale ruler that has a 1:250 on it, and there are even some that are in thirds. But typically, your builder's scale rulers, and because it's standard and because it's process, the vast majority of your scale rulers are going to have 1:20, 1:50, 1:100, and then that can be extrapolated to 1:5, 1:10, 1:20, etc. Because we can just multiply things by 10. But we're dealing in increments of 1:2, 1:5, 1:10, etc. So we're not dealing with increments of thirds or quarters or 1:250, etc. So details 1:5 and 1:10. Sometimes 1:20 for large details. Then sections 1:50. Floor plans 1:100. Site 1:200 for those, and then localities at 1:500. So you see that continuity happening there. We've got 1:20 is basically the same scale as 1:200, 1:100 is that, etc. On your site plans, you've got to include what features are pertinent. Basically, you've got to show where the house is primarily you're going to show where the house is located on the site plan, and you're going to provide some reference of that to a known point, a fixed object. So what we do know, or what the surveyors know, and what is legally documented, is geographically where those boundaries are located. It's all recorded within the Lands Titles Office. You may need to have that defined on site. So on a new development, they're all pegged out, and that's fairly easy to see. On established properties and rural properties, the boundaries are not always easily determined and defined, and you may need to have a surveyor come on site and determine the exact location of that boundary. But when we produce our site plan, we assume that boundary has been determined, and we provide a reference of where our house sits in relation to that boundary. So here we have a dimension line heading off from the building to the boundary, saying this is how far the building is to the boundary. Also, we place the building correctly on that plan, and builders can get other points with their scale rule if they wish, or if they need an accurate pinpoint, they can phone you up and get that accurate pinpoint. So we put the house where we want. And that's a bit of a what you prefer as a drafter, or what you want to convey. Some drafters will show their roof lines on a site plan like that. Others won't. Others will show their walling and then just a roof outline. for that walling it. Either way, typically what you do not do is show your walls and also your roof line, then it starts getting a little bit too confusing. So shown our roof line on there, shown the location of existing vegetation. So on this one they haven't said how large trees are. In some instances they will, or they'll provide a legend. So they'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then over on the side have a legend of tree number 1 is this type of eucalyptus. It is this tall and approximately this age. That might be important information for the council, particularly if it is a significant tree. So include existing vegetation, and also what I show on my plans are any trees that need to be removed. So the trees will be there. Let's say we've got a tree underneath the house. I put that on a very light layer. Then provide a leader to that saying existing tree to be removed for the house to go on. And that provides that information to council and also to native vegetation for any compensation you may need to make for the removal of that tree. I showed boundary as a dot and dash line like this, and put boundary dimensions on there. So how many meters long that boundary is, and also angular dimensions in the corners here as well to show what the angles are. All of this information can be gained from the survey plan image on the title or survey plan image that you order from the Lands Titles Office. You can get that information accurately and import that into CAD. So up in the corner here, there's an excerpt from the survey plan image shown there. I will also include contour lines. So showing the slope of the allotment and the contours of that, they've been missed out on this plan, but often, and particularly on a sloping site, that's very important to show, because then that will also tell council how high some of your retaining walls are, if you've got to be doing some cutting, filling, etc. And that's other things you show on your site plan, or possibly if it's getting too busy, you do a separate site works plan. So a plan that has all your contours, your cut and fill information, and retaining wall information, and disposal of stormwater. You can include that on your site works plan, or on your site plan. You show your disposal of stormwater, and that's been done here with these dashed lines. It's a little bit too small for us to see, but I imagine this leader here talks about the stormwater and that going to 3 cable. So typically it would be like 100mm diameter UPVC pipe to street water table. Certainly includes your title and your scale. You may include inverts or access to the property over footpaths, etc. You may include your water table level. I've only included that on one site plan ever, so not by no means very common. Some sites you'll deal with subject to flooding, and you're going to have to show particularly your finished floor level, that it's up off the ground to a certain height to do that. So a building in Clare that we did had to be raised a metre off the ground to satisfy the requirements there with the flooding in that creek. But if you're doing work out some bits in Virginia, Two Wells, Lewiston, that's in a floodplain, and you have to pick the floor level up 400mm up off the ground. Easy way of doing that is with waffle pods, which are big styrofoam blocks. So rather than digging trenches into the ground, you use void formers on top of the ground, and then you pour your slab on those void formers, and then you end up picking your floor up to about here, like that, by doing that. So you produce a slab on ground, but it's actually up above the ground, and that satisfies those requirements in those floodplains. So that's a way of getting around that. So bench levels and finished floor levels. drainage services, so what we're doing with our stormwater, and any septic tanks, rainwater tanks, etc. I can think of a couple more things I'd put on a site plan. Can anybody else think of something else we put on a site plan?
A north symbol?
A north symbol, yeah, definitely, yeah. No, that's, yeah. Do we have one on there? No, we don't. Fantastic. Yeah.
It is there.
What, it is there?
Yeah.
Where is it?
It's a little bit.
Oh yes, it's really faint, very faint. Yeah. Yeah. I include north symbol in my title block myself. So that way, because that's another thing you do with your drawings is do not produce a drawing where the building is faced this way, and on the next page produce a drawing with the building facing rotating at all. Keep the orientation of your building consistent all the way through your drawings. So that will mean at some point in time you're going to have to decide, okay, this plan that I'm doing, I need to do this plan to this scale. Is it going to fit, as this way or not? So it's a bit. So you have to employ some forward thinking at times about that. But always keep your buildings rotated in the same direction. Obviously, with elevations, that's the correct count because elevations are the plan. But then all I need to do is do my north arrow once. It sits in my title block, and then once I've set up a page, I use that page throughout all of my drawings, and then for things such as kitchen elevations or for external elevations, I just take the north point off title block. So remove it, but then it's set there in the title block for all drawings, and it's the same all the way through. Anything else that should go on a site plan?
What about beacon numbers?
Numbers?
Beacon.
Beacon?
Yeah.
What are beacon numbers?
Yeah. You don't have it?
No.
The surveyor, that is the spot that they mark, for the boundaries.
Oh, right. Okay. Yeah, maybe we do have that. It's something I haven't encountered. So, yeah. So is that a new way of
For you to know your boundaries from your neighbors and the rest of it. That's why it's necessary to have the beacon number, because it's the town authorities and the surveyors, they are the ones that provide the beacon numbers.
Right, and is that a new thing?
I don't know.
You don't know? I'm gonna look into that, because that's something I haven't heard of yet. So, but of course, why not? There is GPS technology is being able to get so fine now that why not have like you say, like some geographic identifier of exactly where in space your boundary starts and finishes. So I'm going to look into that. So beacon numbers. Yeah. Anything else? I would include driveways and footpaths on there. I would include fencing if there's significant fencing anywhere.
There should be a driveway.
There should be a driveway, yes, there should be a driveway. And council are going to want to know that. If you do a building without a driveway, council are going to go, council will most likely stipulate that you will have to have a driveway, but you will have to have vehicular access. They don't like approving things without vehicle access. Yes, you can have buildings without vehicle access, and so on, although, still for emergency services, etc., they want vehicle access. But I guess a relatively unique example of a recent development is the Arts Eco Village at Aldinga. They've got vehicle access to all the buildings, but it's discouraged. So you've got your car parking out in front of the Arts Eco Village, and then minimum access. But you're always going to have vehicle access to your buildings for if an ambulance needs to arrive or if the fire truck needs to arrive. And on rural properties, you're going or any building that you're doing more than 30 metres away from the street front in a bushfire prone area, you're going to have to provide CFS access somehow, and that CFS access has to be designed. I can't remember the number of the Minister's Code, but there's the Minister's Code which stipulates how CFS access should be designed, and we'll go through that as the last topic of this subject. But you will have to provide a track, or the basics of it, a track of 3 metres wide. You can't have a slope of greater than 3.5 metres rise. Sorry, 1 metre rise and 3.5 metres of run. So that's sort of about that slope there. You have to have turning circles of, I think, a radius of 12.5 metres, so 25 metre wide circle for turning a truck around. And so in some instances that can be very hard to achieve. With buildings that are, let's say, only 40 metres away from the road, what you can typically do is have an arc for the CFS truck to come in and turn around. But certainly for building in the hills, you're going to have to gain approval of the CFS, and that's going to include designing access that complies with the Minister's Code. And that's about all we'll include on our site plans.
Okay, let's try triple click to see what happens. Triple click.
So floor plans are going to be a scale as to 1 to 100, and they're going to be dimensioned. Like other aspects in documentation, what we don't want to do is repeat dimensions too often. And once again, for that same reason, that if there are any changes, we don't want to have to be making those changes over various different areas, and then run the risk of missing out, changing our dimensions somewhere. So we dimension our floor plan, and with our dimensions, I'll just get rid of these. Oh, can't. Great. I'll use a different pen. With our dimensions, let's say this is our very simple floor plan. We've got a wall happening in here, and so some width of our external walls, etc. We will do our first dimensions like this, and we'll show these numbers, and those ones. So we're dimensioning from here to here, there to there, there to there, and there, etc. So our first line of dimensions is further in the building. After that, let's say we've got a window happening here. So we can chuck in a window there. That we will do dimension but like that, or we may even completely exclude that one because we don't need it. We've already got dimension there like that. Somebody can work out that distance if they need it, and then provide an overall dimension. So the way we do our dimensions, our first layer of dimensions are further in the building, and as we get subsequent layers of dimensions, they're set further out, and then we have an overall dimension that you can work from. So all of our floor plans have all of our horizontal dimensions. So it shows where things are located in a geographic sense. Our elevations also, our elevations are typically going to be at that 1 to 100. Sometimes we might fit them in a 1 to 50 if it's a small building. Our elevations give us the opportunity for doing any vertical dimensions. So heights from a given finished floor level or a datum. So a datum set on the site plan, and then we can provide all of our vertical dimensions. We may also be required to do a section. Not all councils require a section, and not all buildings, but sometimes a section is very important, particularly for building rules to consent to show various details. Certainly if we've got a detail happening like this where we've got a pitched roof hitting a flat roof, how we're going to get all that framing in there to work. So there's no way we can convey that information without doing a section. Our sections also enable us to call out where we're going to do some construction details. So typically we can draw something on a plan or elevation or a section, but we also need to specify to build it exactly how that can be built. So sometimes the builder is going to go, oh, okay, that's very standard, that's timber framing, I do my stud clusters and so on, how I do them, and that's all going to be very easy. But I can't think of any tricky details. I'll look for some tricky details in this room. Yeah, unfortunately there's not actually anything really tricky in this room because it's all very sort of standard. So your glaziers, or the people producing these window frames would have had let's say a plan detail for this boxing in here, how we produce that boxing in there, and where the mullions sit within that and how they interact with that. So they'd do a detail of that. But cutting through this building, I imagine we'd have some interesting details in various different aspects that would have had to have been conveyed to the builders how those elements interact. And the way we call them out is, rather than produce an elevation and then have a circle saying, okay, construction detail Eve here, like this, we do it in a section. So we do a section drawing as it cut through the building, and then have our detail call out happening over that. So it's actually simply an expansion and an addition of information into a section which has already been drawn. So that's how we call out the section details. We'll also have to do roof and wall frame layouts. So that's not a roof and wall frame layout. It's a wall frame layout for just some very small aspects. You may need to look at this on your screen. It's probably a bit too faint here. But the way that that's being produced is you get a very simple outline from the floor plan. You remove almost all the superfluous information. You even remove the doors and windows and just put small rectangles in place of those doors and windows, and then have that on a light line weight, let's say 0.09, and you might have the transparency of that turned back a little bit if you wish, but a very light line. And then that block gets used underneath where we put all this information about our walls. So we put information about the walls on top of that block, and that's on a much heavier line. It stands out, we can see that information. So that's what's happened there, and that's typically what we do for wall frame layouts, and we do the same for roof framing and services, etc. Once again, as mentioned, you need to have footing report and soil report, so that's going to come from the engineer. And engineer's calculations. In there it says lintels, columns and beams. So typically, yes, there are many design tools available for designing all of your timber framing lintels. Did I mention those previously? Any of that stuff previously? So various different timber suppliers like Carter Holt Harvey produce a program called Design IT, where you can put in all your information, your timber framing information about, relevant to an opening. You've got an opening in a wall, you put in all your information there, your roof load width, etc., and it'll tell you what size piece of timber you need on top of your window there, be that natural sawn timber or be it a manufactured timber like a laminated veneer lumber, so LVL. So that can all be done. We typically don't need engineers for designing and specifying lintels. You can do that in accordance with the timber framing code or in accordance with these design programs. But in some scenarios you will. Let's say if you have to put in a universal beam or hot rolled steel section, you'll need to have an engineer specify that. But certainly with columns and any major beams, we'll have to have engineers
So 0.
specify those as well.
Happy Women's Day to you guys.
So specification provides detailed information of material and workmanship used in the project and any other information not shown on drawings.
Okay, so 2018.
Timber design information, so layouts, wall frame, roof frame, floor frame, wind speed calculations. If you are going to go calculating your own wind speed, there's the option of finding out wind speeds from the SA map viewer for metropolitan areas. Outside of that, somebody will have to determine the wind speed, be that your engineer or yourself. It's not too difficult to go doing it yourself, and there are design tools available for doing it yourself as well. Or you can do it through the code. So there's an Australian standard for determining wind speed, and we won't go into that. But I wouldn't say it's simple, but it's not it's not beyond anybody to learn how to apply that code and determine wind speeds for themselves. It can be handy to determine your own wind speed, or have a wind speed determination done right at the start, so you don't get various different consultants determining their own wind speeds, which can happen in a project as well. So you can determine a wind speed, and then you can have an engineer who's doing portal framing for you determine a wind speed, and then somebody else who's doing some roofing for you determine a wind speed. And if you've got inconsistencies within your wind speeds in your documentation that goes to council, that can be a real headache. And they're going to say, okay, who was correct in the determination of this wind speed? So, yeah, I've seen that happen before. So if you're going to employ an engineer for certain things, yes, maybe go with their calculation of the wind speed, because they carry that liability, but it can be done yourself. Tie-down calculations of bracing. So for your building rules consent, you're going to need to have that.
Yes or no?
A common thing I've noticed in the site visit reports for this subject from students previously is there's a confusion between tie downs and bracing. Does anybody know what a tie down is, or do you all know what tie downs are? So when we build a house, or once a house is built and we've got a strong wind pouring over the roof of the building, it creates suction and it wants to rip that roof off to a certain degree. So obviously the weight of the roof is acting against that. And in some scenarios, particularly with a sheet roof, it can a strong wind can pull a sheet roof off. Now, to ensure that doesn't happen, the timber framing code specifies certain tie downs for scenarios. Now, that tie down might be something as simple as a bugle batten screw. So, type 17 screw, like screws about this long, 75 millimeters, that screw in timber, that secures the batten to the rafter. That's the tie down you need for that scenario. Other scenarios, you'll need to employ a galvanised iron strap. So there's this strapping that you'll see it used in building all the time. It's 30 millimeters wide by 0.8 millimeters thick, this galvanised iron strap that loops over elements, and then you use little galvanised cleats or nails to nail that strapping down. That's another form of tie down. And that particular tie down is used a lot through the frame, so you use it over your rafters to tie your rafters to your wall frames, and then from your top plate to your studs to tie those together, and then from your studs to your bottom plate, so under the bottom plate, tying up to your studs. You have that 30 mil galvanised iron strap. The thing is, that 30 mil galvanised iron strap is exactly the same strap that you use for type D bracing. So a lot of the bracing you'll see in timber frames, that X bracing, that's type D. That uses 30 mil by 0.8 gal strap, exactly the same stuff you use in your tie down. And so I've had students that refer to bits of tie down as bracing and bits of bracing as tie down. And that confusion arises because it's exactly the same material, but it's called different things because it's used in different scenarios. Tie down is to stop things being pulled up and taken away. Bracing is to stop things going sideways. and we can get into that a bit later on as well. So tidal calculations, bracing. So if you're tidal calculations, you're going to need to know the wind speed, and then through the timber framing code, it specifies based on your construction and shape of the building, what uplift forces there's going to be, so what tie downs you're going to need, and then, or what racking forces, the wind pushing on the side of the building, what bracing you're going to need to counter that. Or you can, or your engineer can specify those as well. Once you've done all that, you're going to provide 3 copies of documentation to the council. They'll keep 2 copies and they'll return 1 copy to you, and it will be dated and stamped. Exactly the same date and stamp that they keep on their copies themselves. So they'll get all 3 copies, they'll keep 2 of them, date them and stamp them, they'll send 1 back to you. That just ensures that when you've got those plans dated and stamped, you have to build according to those. You can't then just go produce some amendments and go, oh no, these are the ones you certified with these amendments, because they won't have the dates and the stamps on them. That's it for that slide. Now we can go through the process of supplying all of our plans to council, and then have council do the determination with building rules consent. But there are drawbacks in doing that. One of the drawbacks in doing that is that you can wait around for a long time, and then if your plans do not meet building rules consent, you then have the issue of council not providing you information on how to meet that building rules consent, or where it is your plans don't meet that building rules consent. So you can put your plans in, they'll sit there for a month, then get assessed, and then they'll be sent back to you unapproved, and then you'll have to find out what amendments you can make. Hopefully you get them all, you send them back in, they'll sit there for a month, and then they may or may not be approved. So that can be a very laborious process if you're not confident about the approval, or the quick and easy approval of your plans. So to get around that, you can employ a private certifier. Private certifiers are people who have the right qualifications and insurance to be able to determine whether a set of plans meets the building code. So they can go through your plans and go, yes, everything meets the building code and relevant Australian standards, this is fine for building, and they submit that to the council, and the council says yes. Because the council is bound to, if it's approved by a private certifier, the council is bound to, as far as I know, bound to approve those. So they do that work for the council. What you cannot employ a private certifier to do is to do the planning consent. So the issues around what the building has to look like, what its setback is, what materials and so on it needs to meet the council's requirements. You can't get a private certifier to approve those. The council has to do that first stage. Other things they can assign building classification, can modify building rules application or vary applications as they see fit. They'll do that in consultation with you or as a drafter. They'll provide provisional building rules consent, but cannot provide development plan consent. Must be qualified, experienced and insured.
Alright, so we go back to click on the documents. Click on the documents here.
So notification, 1 day's notice to council and other authority, and inspection at commencement and completion by council and engineer of excavation. So the council's going to want to see when you've excavated your trenches. Steel fixing stage, so that's all the steel that goes in your trenches and into your slab. The council is going to want to see that. They will also want to see wall and roof frame. And I want to see all those aspects because they are very important structural aspects that once the building progresses, those aspects can no longer be seen. So our trenches and our steel work, once the concrete's all in there, who knows what was in there? Who knows what size bars or even what the width of the beams were? So council want to make sure that you've done everything according to the plans that you've provided to them. The only way that they can do that for the footings is to look at it at trench stage and steel fixing stage. And also with your wall and roof frame, those frames all get enclosed later on by, let's say, brick veneer and internal linings and sheet or tile roofs on top. So council's going to want to see those. So to be a builder, it's an interesting one that almost anybody can be a builder. So as long as I've got enough money in the bank, and I can show that. So actually, I think for the criteria there. But if I have enough money in the bank, I can go down to the Office of Consumer and Business Affairs, and if I don't have a significant criminal record or anything that applies to financial mismanagement, and I'm not an undischarged bankrupt, I can go down to the Office of Consumer and Business Affairs and say, I want to have a builder's license. And they can go, oh yeah, that's fine, you can have a builder's license, you've got enough money to do that. You also need to have experience and qualifications in business. So to say, I can run a business, but a doctor, an accountant, or anybody who has experience in running a business can actually be a builder. But what they cannot be is a site supervisor, and we'll get into that. But although with that accountant who is the builder, they will of course need to employ the whole list of subcontractors for doing all of that work. They can't then go, all right, I'm going to do the timber framing, I'm going to do the roof, I'm going to do the roof guttering, I'm going to do the plumbing, etc. They can't go ahead and do that. So typically you do have people who have certain contractors' licenses, etc., becoming builders, but it doesn't have to be the case. But if you have a contractor's license, then that enables you to contract for the various different aspects for which your license includes. So you have various different limited licenses. So I have a license for doing carpentry, I have a license for doing plumbing, I've got a license for doing whatever. That limits me to doing those works. So this is more your builder's requirements. So required knowledge of business operations, able to carry on a small business, must be financially viable, good character, not an undischarged bankrupt. So you need to have a national police clearance with that as well. But what you will not have, and what you will really want as a builder, is supervisor's registration. So the site, and this legislation has really tightened up in the last couple of years. So now for doing any significant building work, I think it's building work over $12,000, you're going to have a site supervisor there. And that site supervisor is going to have to check off all of the aspects of the building until it's complete to be able to give certificate of occupancy. So when we put in that application to the council, we're going to have the builder specified and their indemnity insurance, but we're also going to have the site supervisor specified as well, because we can't have a builder without a site supervisor. Obviously, what's the best case scenario is if you're a builder and you also have your site supervisor's registration and an unlimited license. So unlimited license means you can build up to any value of building, and you can monitor those building works. But your site supervisor's license, typically they have many limitations on them. So you start out and you get a site supervisor's license that enables you to do maintenance and additions up to $30,000. Then you get one that enables you to build buildings up to the value of $150,000, etc., 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 as you gain more experience and more financial backing. But you need to have experience and knowledge to supervise the works. You have to have nominated references, so people that say, yes, Mike does know what he's talking about when it comes to supervising a building site. You'll need to have building qualifications and supervisor experience. And this all gets assessed. So when you go into the Office of Consumer and Business Affairs, you put in your application for that, and then you have an interview. And so you put in all your information beforehand, your CV and all your references, etc. And then in the interview, they'll ask you, what experience do you have? Do you know about these sort of things? And they'll give you some questions and so on to answer and all that sort of stuff. And they'll assess whether you know what you're talking about or whether you don't know whether you're talking about. And they'll determine, okay, you can have a license, and that license is going to be capped at X. So that's the two tiers of certification you're going to require to get a building happening. Builder's indemnity insurance. Insurance is taken out by the builder to protect the owner from non-completion of works or non-rectification of faulty works if the contractor becomes bankrupt, dies, or defaults in any other way. All licensed builders are required to take out indemnity insurance on contracts over $12,000, but some councils require less than that. So that is also council specific. You'll have councils that say, oh no, you need to have builders indemnity insurance for that retaining wall, which only costs $2,000 to install. And I use the example of a retaining wall of $2,000 because with retaining walls, yes, it might not cost very much to install, but any rectification of faulty works can be incredibly expensive afterwards. Let's say we build a retaining wall, the retaining wall is cheap, and then we build a house on that platform which is retained, and then years later that retaining wall is shown to be faulty. It can be very expensive to reinstate that retaining wall whilst maintaining the structure above it, etc. So some councils will want to have builders indemnity insurance for values much less than that, but $12,000 is the mandatory cut-off. So the Construction Industry Trading Board levy, so 0.25% of contract value, must be paid before development approval is granted, and that pays for, I think it contributes towards the TAFE and towards training of various different trades and builders. Building contracts. So typically you're going to be dealing with domestic contracts, and you can get pro forma contracts from the Housing Industry Association and the Master Builders Association. So I'm not sure what they cost. I don't think it's very much to get a pro forma contract from them. That is a contract that stipulates everything to do with the building contract in a standard fashion. So you need to only fill out the particulars, and then you have your building contract. With commercial contracts can vary significantly more than residential contracts because there are so many other aspects to be considered and so many, financial and business permutations that are involved in the drafting of commercial contracts and the completion of commercial works. And so those commercial contracts have to be drafted in accordance with Australian Standard 2124. I think we're near an end. That's the end. So, and with 10 minutes to spare. So not a great early minute. But so what's that? No, it's not Dropbox. It's a
Google Drive, sorry.
Yeah, well it's a facility within Moodle. So if you scroll down, you do it through this grid here, the assignment submissions. So right at the end of everything, there's this grid here for assignment submissions, and you click on that and you upload your assignments to there. So all your assignments are submitted via Moodle, except what typically happens with that first assignment that has a lot of council documentation and so on. What a fair few students have done previously is do hard copies of those assignments and then bring them to me in the class, because if you've got forms that you've filled out manually, to then go and scan all that information and produce a PDF, it's easy for some students, not easy for others to have access to that equipment. So some students have brought them in, submitted them physically, and that's fine. I'll accept that. Although, with a lot of your council information, a lot of that stuff can be done online now, and you can fill out all the particulars online and then produce a PDF from that. And so it may be that it is much easier for you to produce produce that assignment as PDF and upload it to Moodle. Either way, that's fine.
One more question.
Yeah.
Like we are working on assignment. It sometimes take time.
Yes.
Can we submit the assignment in parts or no? Once it is completely ready, then we have to upload.
Yes. No submitting of assignments in parts. But what you can do, if you want clarification about things, you can certainly see me after the class about various aspects with your assignments, or you can submit them as a draft. You say, look, I'm submitting this as a draft. Can you have a bit of a look over that? Tell me if I'm heading the right direction, doing the right thing. But what I do not want are assignments that come as parts. That it becomes way too confusing to ensure that everything has been addressed correctly. And also on that, submit your assignments as a PDF as well. So everything should be submitted as a PDF. If you have issues with that, let me know. Producing a PDF with your computer, but that ensures that I can open that myself at home on my computer, and the fonts and layout is not going to be all over the place. Because what we don't want is some inconsistencies between programs and things not being able to be opened. So put it up as a PDF. That way I can look at it on whatever device I'm on. And any more questions in regards to that? All right, fantastic.